So we're going to take up the review sheet that I gave you from the grade 9 chemistry. So just classification of matter. So you spent a lot of time on this last year, and we're not going to get too much into it this year. We do make references when we do our labs and whatnot to the types of substances, but other than that, we're not going to be at all, we're not going to get too crazy talking about heterogeneous mixtures and homogeneous mixtures, okay? So classification of matter. So matter, this is, you can't see it because of the light here, but this is matter, takes up space and has mass, okay? It can be broken down into two things. It can be broken down into mixed substances, or it can be broken down into pure substances. So we have our mixed substances. These are called our mixtures. These are made up of components that are not found on the periodic table, okay? So we have our homogeneous mixtures and our heterogeneous mixtures. So a homogeneous mixture is one phase, so it looks uniform. I always think of it and I always compare it to homo milk, right? Like it looks uniform, it's all white, right? So that is just the one, right? There's only one phase, you can only see one thing, and those are our solutions that we look at. And we're going to do a lab tomorrow, and I do mention solutions in our lab tomorrow. So you do get referenced about those in our labs, but that's about it, okay? So our heterogeneous mixture, okay? So this is two different, that's what hetero means, right? Two or more phases. So your non-uniform composition, right? So you can see the different parts of it, okay? That's your mechanical mixture. So you can see all the different parts. And I know like a big one that they use in grade 9, they'd say like chocolate chip cookies or pizza, like you can see all the different parts of it. That's your heterogeneous mixture, okay? So all to that, it's the one side is mixtures, okay? On the other side, this is what most of this unit is about, and we're going to really dive in and talk about your elements and compounds here, okay? Your pure substance. These are components made up of, these are your substances made up of components found on the periodic table, all right? So when you see the names, they're from the periodic table. And they always contain one phase. So they're always homogeneous, right? So you can have one of two things. You can have your element, which is just like, you know, a ton of hydrogen, right? So they're all going to look the same. That's going to be your homogeneous, okay? With your element, it cannot be broken down any further, okay? So you have your atom. You have your hydrogen atom. Okay, your atom is the smallest part of it, right? Because you can have hydrogen and there's, you know, hundreds of hydrogen atoms within it. But when you get down in the smallest part, it's just one of those hydrogen atoms. But you cannot take the pieces apart and still have the characteristics that make hydrogen hydrogen, right? So we've talked about subatomic particles. So we've talked about your protons, your electrons, your neutrons. And yeah, you could say, well, those are smaller than a hydrogen atom. Yes, but they are not going to make the same, you know, if you took an electron, it is not going to have the same characteristics as a full hydrogen atom, okay? That's what I want you to understand, okay? So element, that is just one atom of hydrogen, okay? You could have hundreds of hydrogen atoms, but one hydrogen atom is just one of those elements, okay? On the other side, we have compounds, all right? So compounds are going to contain two or more elements. This is what we're going to start talking about today, is the types of compounds that you're going to come into contact with, okay? And there is two types that we look at. So with your compound, this is when two elements come together. The example here is a molecule, which is your water. You have your hydrogen and your oxygen come together to make a water molecule. And I'm going to explain later on the difference, like what molecule is, because not all compounds are molecules, okay? But in this case, we have two hydrogen for one oxygen, and we've just created a water molecule. Okay, so let's keep going here. So what is the periodic table of elements? Okay, well, the periodic table of elements classifies elements and groups them according to characteristics such as mass, atomic number, and your chemical families. Okay, and that's reactivity. So we get talking about the chemical families right after, right? So that's, you know, your families are those columns. Okay, they're the columns, and they're divided that way because it is those valence electrons that have the same, in the same column, they have the same amount of valence electrons, and it's those valence electrons that gives the chemicals or the elements in the periodic table their reactivity or their characteristics, okay? So the horizontal rows of the periodic table are called periods, and there are 7 periods on the periodic table. Elements of a period have different properties, okay? Now the next sheet, I believe, let me just look for it, and then it's got the periodic table on it, and we can kind of talk about it. I think this is the right one. Yeah, okay. So when it talks about, alright, so kind of a, you didn't have to really color it, but kind of an example here. Not an example, I'm just babbling. So elements of a period have different properties. Okay, so the periods they go this way, right? So period 1 just has hydrogen and helium. But hydrogen and helium have very different properties. Helium is very stable, okay, because that's got a full outer shell. Hydrogen is very reactive. This is why we use helium to blow up balloons rather than hydrogen, okay? Because both of these are a gas, all right? Both of these have a lighter mass. Remember that we've looked at the masses underneath. They both have a lighter mass than oxygen, which is why helium, balloons that are filled with helium, float. Because their mass, the mass of a helium atom, is less than the mass of an oxygen atom. Did you know that? Well, now you do. That's why helium balloons float. Because helium is lighter than oxygen. Hydrogen is a gas, and it's also lighter than oxygen. So if you notice the different ones here, that's only helium and hydrogen that are gases and lighter than oxygen. Hydrogen is flammable. We do not fill up balloons with hydrogen because they could explode, and we don't want exploding balloons at kids' birthday parties. All right, so let's keep going. So the vertical columns of the periodic table are called groups or chemical families. So that's these, okay? And they tend to share the same characteristics. There are 18 of them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. You can count. Elements in the same group have the same number of electrons on their outer shell, okay? So periods going across, they have the same amount of shells, right? So hydrogen and helium both have 1 orbital shell. Hydrogen has 1 in it, helium has 2. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, they all have 2 shells, okay? But they all have different amounts of valence electrons in that second shell. These guys, number 3, period 3, they all have 3 shells, sodium, magnesium, aluminum, silicon. They all have 3 shells, though they all have the different amount of valence electrons in that last shell. So they all have the same amount of shells, but different valence electrons. These guys all have different shells, but the same amount of valence electrons, okay? And it's the valence electrons that give them their characteristics. That's why these guys are in families, and they have the same sort of characteristic. These guys are all very reactive with water, okay? Hydrogen is not really part of that family, but it's very reactive, okay? But we used to do an experiment in lithium, sodium, potassium, and we would drop them in water, and they would make like little fire explosions. And as you go down, they get more explosive, okay? You should watch, there's a Mythbuster video, you should watch it. And it shows you the lithium, sodium, potassium, but it shows you rubidium and cesium, and it shows you how reactive they are with water. Like crazy, like as you go down, they get crazy explosive, okay? Whereas these guys, the noble gases, are so calm and collective, and they have a full outer shell, okay? So that's the different families, and they all have different characteristics. So the existing elements are separated into 3 different categories, right? So we have our metals, which is all here over metals, except for hydrogen, over metals, okay? And they can conduct electricity very well. We have our non-metals, right? They do not conduct electricity. They're insulators. So hopefully you remember that from grade 9 last year, right? They don't allow their electrons to move. That's these guys up here, non-metals. Then we have our metalloids, also known as semi-metals, because they have properties of both. And that's these guys down here, the little green guys, okay? All right, so then down here, we're looking at just naming our groups. So we have our alkali metals, which are highly reactive metals. Remember, these guys, highly reactive with water. We have our group 2, which is alkaline earth metals. They're less reactive than the first group. Okay, alkaline here. We have our transition metals, so they have some metallic properties. They're metals. I'm going to get into talking about them today. We have group 17. These are halogens. These are right here. They are also highly reactive nonmetals because they have just one. They have a full outer shell except for the short one. So they all have 7 in that outer shell. So that one missing electron in their outer shell makes them very reactive. And then you have your group 18, which are non-reactive. And then finally you have your hydrogen, which is a gas at room temperature. Okay? But again, same as helium, a gas at room temperature, we just lighter than oxygen. But hydrogen is very reactive. Okay? And then you were supposed to just label them on, and that is great. Now, I believe the next one is, what is an atom? We don't need to get into the whole Venn diagram, blah, blah, blah. So atoms are the smallest part of an element that has all the element's properties, remember? So what I said, there's smaller parts of an atom. So those subatomic particles, neutrons, protons, electrons. But if you're just to take one of those, like a proton, it's not going to carry the properties of that element because it has to have all of the parts. It has to have the neutron, the electron, the proton. Okay? Let's skip over that. It doesn't matter. That's just whatever. So inside the atom, right, we have our proton, our electrons, our neutrons, right? Positive, negative, no charge. These ones are found in the nucleus. They have a charge of +1, and they have a mass of 1. Atomic mass units. Electrons, negative. You know, they orbit the shell. Their charge is -1. And 1,836 of an atomic mass unit, so we technically say there's no mass there. And then you have your neutrons, which are also found in the nucleus. That's why the mass is the neutrons and protons, and they're also 1. And then we have our picture, protons, neutrons, and then our electrons orbiting on the outside. That one was pretty straightforward. Okay, that was what is an atom. So just whipping through this review here. The next one, I'm just going to throw down here. I did go over this part when we were talking about Bohr-Rutherfords, and you were supposed to practice doing your Bohr-Rutherford, as well as how to find the number of protons and the number of electrons, atomic number. Remember I said, though, the protons, really, that's the atomic number, because that is actually what makes an element an element. You can take away and add electrons, but you cannot take away protons or add protons. And then your masses are protons and neutrons, and how to find the number of neutrons. Atomic mass minus atomic number. We went over that already, so I feel like that should be good. Okay. And then talked about, I went over this. We drew our Bohr-Rutherfords. Valence electrons are in the outer shell. When valence electrons are present, an atom can gain or lose electrons depending on how many electrons it requires to become stable. And we talked about that as well. So, what more do we need to go over here? I was looking at all the different ones. But I believe in the next part I talked about, we didn't get into all of this, it was just this here. So what are ions? We talked about that, I went over it, remember? So all atoms are neutral, right? Because they have the same amount of protons, same amount of electrons, but then they start wanting to gain or lose because they want their outer shell to be full. So when an atom gains an electron, there are more electrons than there are protons, and a negative ion is created. Negative is an anion. Okay? When an atom loses an electron, there are less electrons than protons, and so a positive ion is created, also known as a cation. And that's, so a positive ion is cation, negative is anion. Okay? I think that is about all we really need to go over for the review. And then there is a little mini lesson that you're going to go over now in the next video.